Welcome back. Let's talk a little bit about writing formulas for ionic compounds. So we're going to write formulas for what are called binary compounds, which are compounds composed of two ions. These ions can be positive or negative ions from the periodic table, but they can also include polyatomic ions. Remember, the polyatomic ions are on table E. The formula for an ionic compound is also called the formula unit or an empirical formula, and it indicates the ratio of the atoms in a compound. So for example, in NaCl, this means there's one sodium ion and there's one chloride ion. MgCl2, this means there's one magnesium ion and two chloride ions. In potassium sulfide, there's two potassium ions and one sulfide ion. Note that the charges never appear in these neutral ionic compounds. We can always write the charges in to help us, like we did in the last video, but in a formula, they don't appear unless that overall substance is not neutral. When we're writing formulas for ionic compounds on the next few slides here, every compound will be neutral, so our final answer won't have any charges written in it. How do we write ionic compounds? Here's the steps. You can pause to read these now. Let's jump right into some practice. So the first one we have is sodium chloride. So we have to know some things about charges. We have to know that sodium forms a +1 charge. We know this because it's in group 1. Chloride forms a -1 charge. We know this because it's in group 17. Now we got to think about how these come together. Perhaps you can see that they come together in a 1-to-1 ratio. It also might be helpful, though, for us to draw a little picture that shows how they come together. On one side, we have Na+, and on the other side, we have Cl-. The final formula, then, is Na down to magnesium sulfide. Magnesium is in group 2 and forms a 2+ ion. Sulfur, sulfide, forms a -2 ion. Remember, "ide" indicates a negative ion from the periodic table. S2-. We might want to draw a picture here too. There'll be one Mg2+, one S2-. These come together in a 1-to-1 ratio, MgS. Gets a little trickier with calcium nitrate. Calcium is in group 2. Nitrate is a polyatomic ion. Remember, we have to be familiar with our polyatomic ions. These don't come together in a 1-to-1 ratio. Before I draw the picture, you might even think you're going to need one of these and two of these, and if you're thinking that, you're on the right track, because this whole piece has a charge of -1, and this whole piece has a charge of 2+. So this picture is going to show one calcium 2+ ion and two nitrate ions. So how do we write this formula? Well, we have one Ca, and then we have two of the whole nitrate piece. So we put that whole nitrate in parentheses, and then put a little subscript of 2 outside the parentheses. How about aluminum oxide? Al3+ and O2-. This is from using our periodic table. Here, I'm going to not have enough room to draw the picture, but you can draw it on yours. You're going to have 2 aluminum pieces. I'll just draw the circle. And 3 oxide pieces on your picture. How am I going to write this? Well, there's 2 aluminum, so Al2, and there's 3 oxides, O3. This formula would be Al2O3. Here's a few more. Maybe you want to pause the video and try these now. I'm going to go through these without the picture, but remember, you can always draw the picture. Copper chloride is copper 2+. Chloride is Cl-. I'm going to need 2 chlorides for every 1 copper, Cu, Cl2. Remember that Roman numeral here told me the charge on the ion was +2. It does not tell me the number of copper. Calcium phosphate is going to be composed of Ca2 plus and PO4 3-. If I was drawing the picture, I would use 3 of these and 2 of these. How do I write that? I write that as Ca3 calcium ions and 2 phosphate ions. How about iron 2 nitrate? Remember, that Roman numeral tells me the charge. Remember, nitrate is a polyatomic ion. I'm going to need 1 Fe2 plus and 2 NO3 minuses. Just like that. Now it's getting wild. Ammonium carbonate contains 2 polyatomic ions. It contains NH4 plus and it contains CO3 2 minus. Remember, only look at the charges when you're figuring out how many of each ion you need. Don't worry about these subscripts in the polyatomic ion. They get included in the formula, but you're only looking at the charges. What do the charges tell us? Well, for every 1 carbonate, there's a -2 charge. That means I'm going to need 2 NH4 pluses for every 1 CO3 2 minus. How do I write that? Well, I need 2 NH4 pluses. So I put that like this. An additional subscript of 2. Notice I'm not multiplying or distributing anything through. This is a 2. How do I show the carbonate? CO3. Since there's only 1, I don't need any parentheses here. I can just leave it like that. This slide highlights the crisscross method, but you got to be a little careful with this. It works great for something like aluminum oxide. What the crisscross method is it's a shortcut, and it says whatever the charges are on each ion, they become the subscripts on the other ion for a binary compound. You also then have to use the simplest ratio, and this is where it gets tricky. Think about magnesium oxide. Magnesium oxide is going to be composed of Mg2 plus and O2 minus. With the crisscross, you might think the formula is Mg2, O2. But remember, you have to go with the simplest ratio, MgO. How about if we're going the other way and naming ionic compounds? To name an ionic compound, this means writing the English name. It's based on the IUPAC system, which stands for the International Union of Pure and Applied Chemistry. The cation, the positive ion, is just the name of the atom. If it takes on more than one charge, like a transition metal, you use a Roman numeral to indicate the positive charge. Notice that this refers to charge and not oxidation number. We're not talking about oxidation number right now. Things in group 17 only have one charge, -1. You would never use a Roman numeral there because you only use a Roman numeral for a positive ion that can take on more than one charge. Pretty much you only use Roman numerals for some of the transition metals. Writing the English name, the negative ion comes next, and we use the "ide" ending. So an ion from chlorine is chloride, an ion from oxygen is oxide, and an ion from nitrogen is nitride. Notice that sometimes, like with oxygen, the name gets a little shorter. Usually this anion name only has 2 syllables, so we shorten the prefix part to give it 2 syllables. How would you do with each of these? The first one here is fluoride. Chlorine becomes chloride. Bromine becomes bromide. Iodine becomes iodide. Oxygen is oxide. Sulfur is sulfide. Nitride. Phosphorus is phosphide. Remember, ide means from the periodic table, right? Don't confuse these polyatomic ions, phosphate, phosphide, and don't confuse nitrate or nitrite with nitride, or sulfate with sulfide. How would you name these compounds? This one would be sodium chloride. This one would be magnesium oxide. This one's calcium chloride. This one's sodium nitrate. Remember to be familiar with your... This one's calcium nitrate. Notice that nothing in these names tells me how many of each ion there is. For example, there's nothing telling me that there's 2 chlorides. That gets figured out, and if you're still kind of confused on that, you might want to look back at the first part of this video, where I showed you how you figure out what this formula is when you're given the English name. These ones are a little bit trickier. We have ammonium sulfate. Iron. Since iron can take on a +2 or a +3 charge, we got to figure out the charge here. OH is -1, so iron is +2. Iron 2 hydroxide. Iron 3 hydroxide, and this one, iron takes on writing in charges might become beneficial here. This one is copper 2 sulfide. Since sulfide is a -2 ion, copper must be +2 charge. This one, since silver is a transition metal, but it only takes on 1 possible charge, is just silver sulfate. You don't need the Roman numeral here, because silver only takes on 1 possible charge. That was quite the long video, but we went over everything from how to write binary ionic compounds to how to name them. Now it's time for